Good morning, students. Let's continue the chapter Thermodynamics. In previous lecture, we have seen heat and internal energy. What is it? Heat is not something which is contained in an object. Rather, it is something which is transferred in object. Now today, we will see the relation between heat and internal energy. For that, let us consider I was having a very simple system of an glass which is filled with water. Suppose this is the glass and this glass is filled with hot water having temperature T1, and I was having another glass which is again filled with water, but at this time instead of hot water we are having cold water in it. The temperature of this cold water is T2, and around this system there is environment. The temperature of this environment be suppose TE. After some time we observe that the temperature of this hot water go on decreasing and the temperature of this cold water go on increasing, and after some sufficient time interval the temperature of this hot water is equal to temperature of environment, and the temperature of this cold water is also equal to the temperature of environment. There is increase, there is decrease in temperature, there is change in temperature. This change in temperature occur due to the transfer of heat from system to surrounding and from surrounding to system. Let us consider this should be the system of hot water which is having initially internal energy U1, and suppose this should be the system of cold water which is having initially internal energy U2. Now this system that exchange energy to the surrounding. The heat is entered from system to the surrounding. Let Q be the heat which is entered from system to surrounding. Now this system U2, in this system of cold water, the energy or the heat Q is entered from environment to the system, and that's why this system loses energy. And this system gain energy. When this system loses energy, naturally its internal energy is get decreased, and when this system gains energy, its internal energy get increased. So there is change in internal energy when it is exchanged from system to surrounding or from surrounding to system. Now let us see the change in internal energy of a system. Now let us consider a simple system, a very simple system having a cylinder which is having an piston which is movable, which is frictionless, which is massless, and a gas enclosed in it. Again we are having another piston, another cylinder which is again having a piston, and in this cylinder again let us consider a gas is enclosed. Now suppose that for this system, with the help of an burner, we add heat by heating this cylinder, and suppose this cylinder is placed in an cold environment, and that's why the temperature of this gas which is in this cylinder is increased, and temperature of the gas which is in this cylinder is get decreased. When the temperature of this gas is get increased, then its internal energy is also get increased, and when the temperature of this gas is decreased by exchanging heat to the surrounding, its internal energy is also get decreased. So this is one way to change the internal energy of a system, by adding heat or by removing heat from the system to the surrounding. There is another way to change the internal energy of a system. Again let us consider we are having the same piston. Suppose this is the piston, and suppose this is the cylinder. The cylinder is having this piston. This cylinder is having a gas, and we are having another cylinder which is having a piston. The cylinder is filled with gas. Suppose this is the gas. Now in first case, the gas that strike on the wall of the piston, and when these atoms of gas they strike on the wall of piston, they lose their momentum. The momentum is gained by this piston, and this piston is moved in upward direction as shown in figure. These are the new positions. This is the displacement. Now this piston moved in upward direction, and that's why its volume get changes from Vi to Vf. There is change, there is increase in volume of this cylinder. In this case, work is done. In this case, work is done by gas. Work is done by gas on the piston. And suppose in the second case, we push this piston in downward direction, so that these are the new positions of this piston. The piston is get displaced by this much distance. This is the distance. In this case, the gas is get compressed. The gas is get compressed. So in this case, work is done by piston on gas. Let us see what happens when this piston is moved in upward direction. As I have already mentioned, that when this gas molecule they strike on the piston, they loses their momentum, and that's why their velocity is decreased. And when their velocity is decreased, then their total translational kinetic energy is decreased. As a result, their temperature is also get decreased, and that's why the internal energy is also get decreased. In the second case, when this piston is moved in downward direction, then the gas molecules they gain the momentum, and as this gas molecule gain the momentum, they are moving with larger velocity. That's why their temperature is increased, and when their temperature is increased, there is increase in internal energy. So in this way, the internal energy of this gas is changed by doing external work by the system or on the system. When work is done by system or on system, then there is change in internal energy, and this is the foundation of first law of thermodynamics. And now let us see first law of thermodynamics. Now let us see this case. Suppose P be the pressure of gas, A be the area of cross section of the piston, Vi be the initial volume of the gas, and the volume is changed from Vi to Vf when this piston is moved in upward direction. In this case, some work is done. Suppose the work done is dW. This dW is equal to force into displacement. We know the relation that pressure is equal to force upon area, which implies that this force is equal to pressure into area. Now let us substitute the value of F in this equation. What we get? We get P into A into dx. A into dx is nothing but the change in volume dV. So the work done dW is equal to P into dV. We are interested to find the total work done when the volume changes from Vi to Vf. So we integrate this dW, then we get W. The limit of integration are from Vi to Vf. W is equal to P outside the integration, and the limits of integration are from Vi to Vf into dV. Integration of dV is equal to V, and the limits, they are from Vi to Vf. Now let us substitute the upper limit. What we get? P into Vf minus Vi. This is the change in volume into pressure. This much work is done. When work is done by gas on piston, then this W is positive, and when work is done by gas on piston, then this system loses its internal energy, then this del U is negative. And in previous example we have seen that when heat is added to the system, then this del U is equal to Q. The heat added to the system, that will absorb by the system, and that's why the internal energy of this system is get increased. Now these two observed things, they are collected in an equation, and we get the equation for internal energy. Del U is equal to Q minus W. This is the mathematical form of first law of thermodynamics. It states that the change in internal energy is positive when heat is added to it, and the change in internal energy is negative when work is done by the gas on the piston. Now let us see the statement of first law of thermodynamics. The change in internal energy, this del U is nothing but the change in internal energy of a system of a system is the difference between the heat supplied to the system and the work done by the system on its surrounding. This is the statement of first law of thermodynamics. What is statement? The change in internal energy. This du is nothing but the change in internal energy. The change in internal energy of a system is the difference between this negative sign that indicate the difference. The change in internal energy of a system is the difference between these two quantities, difference between Q and W. What is Q? Q is heat supplied to the system and W is work done by the system. So the statement of first law of thermodynamics is the change in internal energy of a system is difference between the heat supplied to the system and the work done by the system on the surrounding. Okay, thank you.